So, good day everyone. So, I'm Monlene Grace Bansil and I'm going to tackle about the chapter 4, the standard error of the difference between two scores. So, the outline of the presentation, the standard error of the difference between two scores. First, appropriate statistical tool to address three types of questions. The formula for the standard error of difference between two scores. So, let's first introduce what's the use of standard error of difference between two scores. So, error related to any of the number are possible variables operative in a testing situation can contribute to a change in a score achieved on the same test or a parallel test from one administration of the test to the next. So, the true difference character true differences in the characteristics being measured can also affect test scores. These differences may be of great interest, as in the case of personnel officer who must decide which of many applicants to hire. Indeed, such differences may be hoped for, as in the case of psychotherapy researchers who hopes to prove the effectiveness of a particular approach in a therapy. So, the amount of error in a specific test score is embodied in the standard error of measurement, but scores can change from one testing to the next for reason other than the error. So, comparison between scores are made using the standard error of differences, a statistical measure that can aid a test user in determining how large a difference should be before if it is considered statistically significant. Um, as you are probably aware from your course in statistics, customs in the field of psychology dictates that if the probability is more than 5%, that is the difference occurred by chance, then for all intents of purposes, it is presumed that there was no difference. And also, a more rigorous standard is the 1% standard. Applying the 1% standard, no statistically significant difference would be deemed to exist unless the observed difference could have occurred by chance alone less than one time in 100. So, ano ba ang use ng standard error of difference between two scores? So, as the example, yung kanina, halimbawa, merong position sa isang company na, halimbawa, mag-ano kayo, maging manager. So, merong test na gagawin para para malaman kung sino yung able na person para sa pagiging manager. Pag makikita dito kung ano yung strength and weaknesses ng mga applicants, and also dito din makikita kung halimbawa nasa case kayo ng psychotherapy na researcher kayo, makikita dito na if yung approach ba na gagawin nyo sa inyong client or patient is effective or not. Itong gagamitin natin. So the standard error of difference between two scores can be the appropriate statistical to address three types of questions. So what are these questions? First question is, how did this individual perform on test 1 compare with his or her performance on test 2? The next question is, how did this individual perform on test 1 compare with someone else's performance in test 1? And number 3, how did this individual performs on test 1 compare with someone else's performance on test 2? So, as you might have expected when comparing scores achieved on the different tests, it is essential that the scores be converted to the same scale. The formula for the standard error of difference is what you have seen on our screen, where the sigma is the standard error of difference between two scores, is the squared standard error of measurement for test 1, and is the squared standard error of measurement for test 2. If we substitute reliability coefficient for the standard errors of measurement of the separate scores, scores rather. So if we substitute reliability coefficient for the standard errors of measurement of the separate scores, the formula becomes what? Becomes like that. So where R is the reliability coefficient of test 1, R1 is the reliability coefficient of test 1, R2 is the reliability coefficient of test 2, and sigma is the standard deviation. Note that both tests would have the same standard deviation because they must be on the same scale or be converted to the same scale before a comparison can be made. So, the standard error of difference between two scores will be larger than the standard error of measurement for either score alone because the former is affected by the measurement error in both sides. This also makes sense if two scores each contains errors such that in each case the true scores could be higher or lower. Then we would want the two scores to be further apart before we conclude that there is a significant difference between them. The value obtained by calculating the standard error of the difference is used in much the same way as the standard error of the mean. If we wish to be 95% confident that the two scores are different, we would want them to be separated by two standard errors of the difference. As a separation of only one standard error of difference would give us 68% confidence that the two true scores are different. So, as an illustration of the use of standard error of the difference between two scores, consider the situation of a corporate personnel manager who is seeking a highly responsible person for the position of vice president of safety. The personnel officer in this hypothetical situation decides to use a new published test we will call the mindedness test or the SMT to screen applicants for the position. After placing an ad in the employment section of the local newspaper, the personnel officer tests 100 applicants for the position using the SMT. So the personnel officer narrows the search for the vice president of the two highest scores on the SMT. So there are two people, Mo and Larry. So Mo who scored 125 and Larry who scored 134. Assuming the measured reliability of this test to be 0.92 and its standard deviation to be 14. Should the personnel officer conclude that Larry performed significantly better than Mo? To answer this question, first calculate the standard error of the difference. So, note that in this application of the formula, the two test reliability coefficient are the same because the two scores being compared are derived from the same test. So, what does this standard error of difference mean? For any standard error of difference, we can be 68% confident that two scores differing by 1 sigma represent true scores difference. Second is 95% confident that two scores differing by 2 sigma represent true score difference. Number 3, 99.7% confident that two scores differing by 3 sigma represent true scores difference. So applying this information to the standard error of difference just computed for the SMT, we see that the personnel officer can be 68% confident that two scores differing by 5.6 represent true scores difference. 95% confident that two scores differing by 11.2 represent the true score differences. And 97.7 confident that two scores differing by 16.8 represent true scores difference. So the difference between Larry's and Mo's scores is only 9 points, enough not a large enough for the personal officer to conclude with 95% confidence that the two individuals have true scores that differ in this test. So, stated another way, if Larry and Mo were to take a parallel form of the SMT, then the personal officer could not be 95% confident that at the next testing Larry would again outperform Mo. So the personal officer in this example would have to resort to other means to decide whether Mo, Lori, or someone else would be the best candidate for the position. Curly has been patiently waiting for the in the wings, and as a postscript to the preceding example, suppose Larry got the job primarily on the basis of data from a hypothetical SMT, and let's further suppose that it soon became all too clear that Larry has the hands down absolute worst vice president of safety that the company had ever seen. Larry spent much of his time playing practical jokes on fellow corporate officers, and he spent many of his off hours engaged in his favorite pastime or plug full setting. The personal officer might then have very good reason to question how well the instrument called the safety mindedness test truly measured minded mindedness. Or to put it in another way, the personal officer might question the validity of the test. Not coincidentally, the subject of test validity is taken up in the next chapter. So the reference, here it is, the psychological testing and assessment by, yun na nga, 9th edition. That's all. Thank you.